mathematically.
Welcome to the lesson. So in this lesson we are going to cover differentiation, that is part of calculus. And for this lesson I want us to look at stationary points. So let's begin. So we shall use the curve below to learn about the stationary points. So we shall begin by sketching this curve, or rather drawing the curve y is equals to x squared plus 2x plus 3. But before we draw that curve, let's get the gradient function of this curve. That is the first thing you're going to do in order to understand better what stationary points are. So y is equals to x squared plus 2x plus 3. When you differentiate these, you obtain the gradient function. So differentiate it and you get dy over dx. When you differentiate it, this one you get 2x plus 2. So this is the gradient function. The next thing you're going to do is to prepare a table of values with some points of x from -4, in this case from -4 all the way to 3. Then to obtain the gradient at x, this is what you're using, the gradient function that we have just obtained previously. So you substitute -4. When x is equals to -4, just substitute here, you get this is the -8 plus 2, -6, you go filling. So this table of values represents gradient at different points. So the next thing, after you draw the curve, this is what you get. Drawing the curve, we've done this, both the drawing of the curve. So you realize that to this side of the curve, the gradient is negative, dy over dx is negative. Then at this point, the gradient is 0. Then to the right, the gradient is positive. Now you go to the table of values that you've drawn, you realize that at this point, at -1, the gradient is 0. To the left, you realize the gradient is negative. Then to the right of that point, the gradient is positive. That is what you realize. So the next thing I think is just the same thing as we have noted in the previous slide, that at x is equals to -1, the gradient is 0. To the left of x is equals to -1, it is negative. Then to the right of x is equals to -1, it is positive. You can just go back and see that. So you can see at this point, that is x is equals to -1, the gradient at this point is 0. To the right, the gradient is positive. Then to the left, the gradient is negative. Now the gradient of the curve, as one moves from the left to the right, this is something else very important to note, that the gradient of the curve as one moves from the left to the right of point -1, 2 changes sign from negative through 0 to positive. This is what we mean. Go to the curve. So what we mean is here we have the point -1, 2. This is the point. So as one moves from the left through this point to the right, the gradient changes from negative to positive. That is what we mean. So this is the point, -1, 2. So as one moves from the left through this point and you go to the right, the gradient changes from negative to positive. I hope that is clear. Now after noting those points, it is important now to note this. This is also very important, that such a point that is -1, -1, 2 is called a minimum point. That point which you have identified, -1, 2, is called a minimum point. And this is the point we're talking about. So this point here. So this is the point, -1. This is the point. This is here, -1, 2. This one is referred to as the minimum point. Now let's go to something else. And I want us to obtain the sketch of the following curve again. So y is equals to negative x squared plus 4x plus 2. So let's obtain the sketch of this. So the first thing, let's obtain the gradient function. The gradient function will be obtained by negative 2x. When you differentiate this equation with respect to x, you get dy over dx is equals to negative 2x plus 4. Now after obtaining the gradient, we can use this gradient to identify, use that gradient that you obtained there to identify the gradient at different points of the curve. And we're going to do the same thing we've done previously. Get some points and use this point, negative 1 to 5, and use this gradient to obtain. You can use this gradient to obtain this value. So substitute like negative 1. When you negate this one is negative 1, you get negative, this will be 2 plus 4, it will be 6. So go substituting, and this refers to the gradient at these different points. So the next thing, after you draw that graph of that function, this is what you obtain. This is how it looks like. And you notice from that table of values that to this side, the left hand side of this curve, the gradient is positive. At this point, gradient is 0. To the right, gradient is negative. Now you can see this one clearly from the tables. This is the table of values. Now you can see it properly here. So you can see this is the point where the gradient is 0 to 0. To the right, you can see the gradient is negative. Then to the left of that point, gradient is positive. Very important to note that. Now, this is just a repetition of what we have just observed, that the gradient is 0 at x is equals to 2. To the left of x is equals to 2, the gradient is positive. To the right of x is equals to 2, the gradient is negative. So we can just go back briefly. So you can identify the point at which the gradient, this is the point 2, this is the point at x is equals to 2. You can see the gradient is 0 there, and this is the point x is equals to 2. So to the left, the gradient is positive. To the right, the gradient is negative. That is what we mean. Now a point such as 2, 6, at which the gradient changes from positive through 0 to negative, is called a maximum point. So in the previous slide we talked of the minimum point, but now we have this example that gives a maximum point. So this point 2, 6, this is the point. This one is a maximum point because the gradient changes from positive through this point to negative. So this point 2, 6 is referred to as the maximum point. Then something else which is very important to note, that maximum and minimum points are called turning points. This is very important, that maximum point and minimum points are called the turning points of the curve. Now let's consider the last example. Let's get this curve y is equals to x cubed minus 4. So the first thing, obtaining the gradient function, which is given by differentiating this equation with respect to x, you get 3x squared. Then you prepare a table of values indicating the gradient at different points of this curve. So you just substitute 3x squared. When x is negative 2, what is the gradient? Is 12. When x is negative 1, just substitute in this expression, this is 3x squared, the gradient is 3. So this table represents the gradient at different points of the curve. Now when you sketch that curve, this is what you get. So you can see this side, the gradient changes from positive through 0 to positive. the gradient changes from positive through 0 to positive, and that one can be seen properly when you look at this table of values, because this one represents also the gradient. So you can see the gradient is positive, then 0, then positive. So the same way the curve is displaying. Now let's go to something that is very important, a note. Note number 1, it is very important, that the gradient of the curve is 0 at 0, -4. Then to the left and to the right of this point, the gradient is positive. A point at which the gradient changes from positive through 0 to positive, or from negative through 0 to negative, is called a point of inflection. Then note 3, the point at which the gradient is 0 is called a stationary point. I think now we have realized the meaning of a stationary point and point of inflection, and also minimum and maximum points. So just go through these 3 notes, that the gradient of this curve at 0, -4, look at this curve that we have. We'll just go back to that. To the left and to the right of this point, the gradient is positive. And go back to it. So notice that this is the point 0, -4. This is where the gradient is 0. So to the left, the gradient is positive, and to the right, the gradient is positive. That is what we mean by the first note. Note number 2, a point at which the gradient changes from positive through 0 to positive, or from negative through 0 to negative, is called a point of inflection. Like in this case, you can see the gradient changes from positive through 0 to positive. It can also happen from negative through 0 to negative. So such a point is called a point of inflection, not a maximum or a minimum point. Then the last thing, which is very important, that the point at which the gradient is 0 is called a stationary point. Now let's get the summary on how to identify the type of stationary point. Stationary point can either be a maximum point, can be a minimum point, it can be a point of inflection. Now a maximum point is indicated by this kind of a curve. If you look at this kind of a curve, these are starting from positive through 0 to negative. This is the sketch of that curve. This one is a maximum point. From positive on this side, 0, then negative. Then a minimum point, the gradient starts from negative through 0 to negative to positive. I repeat that. Minimum point, the gradient moves from negative through 0 to positive. Then point of inflection is represented by 2 scenarios where the gradient moves from positive through 0 to positive, and this is the kind of a curve that represents that, positive through 0 to positive, or negative through 0 to negative. And that is all about the stationary points. Thank you so much.